Hi there. This set of videos is about using the CEDriverWizTemplates as available on Codeplex. In a nutshell, these templates simplify the development of a simple stream driver for Windows Embedded Compact 7 and provide a number of test applications. This video is about setting the scene for using the templates, that is, why use them. In this version of this introduction video, there are three parts. This is the first part, driver basics. In developing an embedded image for Windows Embedded Compact 7, we use Platform Builder installed with Visual Studio. So you would firstly develop the operating system image using out-of-the-box and third-party components. Out-of-the-box means just those components that are supplied when you install Platform Builder. You then would go on and create your custom device drivers for any hardware, etc. that is not provided out of the box or by a third-party component. Having got your operating system up and running with all the required device drivers, you then would implement your various applications required by your operating system running on your particular device. And you then focus on deploying the whole operating system with its applications, device drivers and so forth to the target device. This wizard focuses on being able to create custom device drivers. Let's just have a brief look at device drivers. A device driver is an interface between the operating system and the underlying hardware. When a device driver is loaded, applications and the operating system then use that device driver to interact with the hardware. Device drivers in Windows Embedded Compact and Windows CE can be looked at on a number of different dimensions. There are device drivers that are native, and there are device drivers that are stream drivers. Native tend to be specific to the particular hardware that's required, for example video and so forth. The stream drivers are where they can be made to fit to a standard interface for the operating system. Secondly, device drivers can be monolithic or they can be layered drivers. Monolithic is where the whole device driver is just one piece, one DLL that is. Alternatively, device drivers can be layered, and this is useful for where the particularly the driver is broken up into two parts, the interface to the operating system and the second part being the interface to the hardware. So we're focused with this wizard on stream drivers because stream drivers have a standardized interface. The other thing with Windows Embedded Compact 7 is to consider whether the device driver is going to run in kernel mode or user mode. This option is facilitated by the wizard, quite simply. So we're looking at stream drivers. Stream drivers provide a standardized interface, standard implementation. So they all have the same basic architecture from a software perspective, which makes the implementation simpler than trying to build a native driver. So with stream drivers, there are the actual standard stream, generic stream that we can create. There are your block drivers for storage, your bus drivers where different devices are connected to the same bus or sub buses, and USB drivers. They're all stream drivers. So some specific examples of stream drivers is just a generic stream driver that you may invent for some general purpose. Serial drivers are stream drivers. Power can be implemented as stream driver. Audio is streamed, which makes sense now because audio is going to be passed around as a stream. The LEDs for embedded hardware are also another example of stream drivers. So the stream drivers have a stream interface, and the stream driver is implemented as a native DLL that implements a set or subset of functions. So a stream driver has to have a init function and a dinit function. These are what are called by the operating system when the stream driver is loaded and unloaded. To access, for an application to actually access data and manipulate the stream driver, there is the open and close functions that the stream interface needs to implement. To actually move data in and out of the stream driver and to do lower level controls and also do data movement, there are the functions read, write, IO and IO control. IO control uses what are called ioctals. There are some of these functions that are optional, in particular the power up and power down functions, which can be implemented. Generally though, you might find that power is actually implemented as an interface through the IO control function. Finally, there are some optional functions of pre-init and pre-close, which take care of housework just before the driver is unloaded with pre-dinit and just before it's closed with pre-close. These can be in particular used for looking for threads that are running, just making sure they're shut down before the actual closing or shutting down of the driver occurs. Stream driver also requires some registry settings to specify some configuration issues to do with the driver. There's the DLL name, there's the prefix. The prefix, for example, like a serial driver will use a COM prefix. That's where we get the COM1 or COM2, COM3 colon. There are various flags. Some of these, for example, specify whether the driver is going to load in kernel or user mode. And also we can specify that various IO control interfaces are implemented by this driver, and the operating system can then exploit them. For example, the power interface might be implemented. So we use Platform Builder installed as an add-on to Visual Studio 2008 for Windows Embedded Compact 7. Using this, we specify the operating system, we build, we deploy it to a test environment, and we test the operating system and harden it. We develop our custom device drivers, and we do the application development, which can be native applications or managed code, as in .NET Compact Framework. And so we see here a typical operating system design implemented as a solution in Visual Studio. We have all the operating system stuff here, and we can create sub-projects of the operating system, applications and application DLLs or device drivers and so forth. And finally, down the bottom we have the parameter files for the operating system that are not part of drivers and so forth. If we create a custom driver, then we would, if we wanted to load at start time, we would put its bib entries in the bib file here, and we put its registry entries in this file here, build the operating system, and it would start and run.